So chapter 13, we are starting trigonometry. So this first section is mainly all a review from geometry, except for this piece in the middle here. The reciprocal trig functions, these three are going to be new to you. So we have cosecant, which is CSC. We have secant, SEC, and cotangent, which is COT. And these are reciprocals of the one that's next to it. So if you look here, sine, you know, is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. And tangent, you have opposite over adjacent, and here it's adjacent over opposite. So this is giving you your ratios for those, your abbreviations, and then if you need a little diagram here, this is what these letters go with. This, if you don't know and didn't use it in geometry, this is a Greek letter theta, and that's most commonly used for unknown angles. So if you used X in geometry or A or whatever, that's fine. We're going to use theta though in Algebra 2. It's most commonly used for an unknown angle. A couple other important things we have on here. These are your special right triangles, your 45, 45, 90, and your 30, 60, 90 triangle. Those are going to be useful for us as well. And then you've talked about angles of depression and angles of elevation. So angle of depression is when you're looking down from the horizontal, and angle of elevation is when you're looking up from the horizontal. So kind of a picture to help you visualize those. All right, first one says find all 6 of the trig functions for our angle theta here. So the first thing we have to do is we have to find what the hypotenuse is. So in order to do that, you could use the Pythagorean theorem, or you could use a trig function if you want. Let's just do the Pythagorean theorem here. So a squared plus b squared equals c squared, and I got my calculator here. And then I'm going to take the square root of that. So it gives me 74. So 74 is what my C value would be. Okay, so most of them, if I do sine of theta, so I'm looking from this angle, opposite over hypotenuse, that would be 70 over 74, which we want to simplify. What is that as? Simplified as 35 over 37. Cosine is adjacent over hypotenuse, so 24 over 74, which simplifies to 12 over 37. And tangent is opposite over adjacent, so 70 over 24, which would be 35 over 12. So there's the first 3 that you should be used to. And then now to get the reciprocal trig functions, this is easy. So cosecant is the reciprocal of this. So this was hypotenuse and this is opposite, so I'm flipping those. And secant is the reciprocal of cosine. And tangent is the reciprocal, or sorry, cotangent. So there's your 6 different trig functions for that particular triangle. Okay, so example 2 says use a trig function or a special right triangle to find the value of x. So let's look at both ways to do this here. So remember, we're only working with right triangles here. If I look from this angle, I have the opposite side and the hypotenuse. So opposite and hypotenuse is going to be sine. And then to solve that, we would multiply both sides by 74. Remember, sine of 30 is a number itself. Also, if we're going to be typing these into the calculator, make sure that you are in the right mode. We got to be in degree mode here. So I got to make sure I select that. So now 74 times the sine of 30 is 37. Okay, that was using trig. Now let's look at our special right triangle. So this is a 30, 60, 90 triangle. which means that would be 60. If you look at these relationships on the 30, 60, 90, the smallest side is x, the hypotenuse is 2x, so the thing you need to remember there is this side is half the hypotenuse, or the hypotenuse is double the small side. And then the other leg, the longer leg, is whatever the short leg is times root 3. So if I look at what I have here, this is the hypotenuse and this is the short side. So this short side is half of the hypotenuse. So if you just do half of 74, that gives you 37 for x also. So two different ways to think about it or look at it, depending on what you have or what you're comfortable with there. Okay, next side. Water skiing competition. We have a jump given here to the nearest foot. What is the height of the ramp here that they're going to go flying off of? So you got your little person that's going to ski up there. If you're looking at this angle and the information that you have the side opposite and the hypotenuse. So I'm going to use sine again. Equals opposite over hypotenuse. You would multiply both sides by 19. And then plug that into the calculator. Oops. So to the nearest foot, I would round this up to 5 feet. Okay, example 4 is a little bit trickier of an application problem because you don't have the picture. So you should definitely draw your own picture for this. So it says, biologist whose eye level is 6 feet above the ground measures the angle of elevation to the top of a tree. The biologist is standing 180 feet from the tree. What is the height of the tree to the nearest foot? So here's my biologist. Here's my tree. He is 6 feet tall, or his eye, up to his eyes is 6 feet. And he is standing 180 feet away from the base. And angle of elevation, so angle of elevation from his eyes then, so here's his eyes, to the top of the tree is 38.7. Alright, so what I do is I sketch a picture of what's going on, and then I just kind of come over here and write a triangle and relabel that. So this is 180, this is my 38.7. We need to find this here, and that's going to be up to this spot on the tree, and then we'll deal with that 6. So from here, I have opposite and adjacent, so I'm going to use tangent. So multiply both sides by 180. Does this say to the nearest foot? It does say to the nearest foot. Okay, so we'll round that at the end. So this, what I just found, was this length. But if we want the whole height of the tree, there's another 6 feet on the bottom there. So I'm going to add 6 to that, which would give me, to the nearest foot, 150 feet. Alright, so you've got the last 2 there. And joke of the day, what are the strongest days of the week? Saturday and Sunday, because all the other days are weekdays. Bet you've heard that one before. Alright, finish up your last 2 problems and have a great day.